So a new open weights model, GLM 5.2, just came out, and I've been running it through a few different tasks. One of them has been to make my kind of Mario style game based on a folder that had a bunch of old game assets. This was a task that Fable 5 did really well, so I wanted to try to see if an open weights model could actually match it. And as you can see here, it did build the game, but watch to the end to see how the game actually plays, as well as a few other tasks and a breakdown in the architecture. So this morning, ZAI introduced GLM 5.2, their newest model, which they're calling a significant improvement on GLM 5.1. And most importantly, this is an open weights model, so we can actually dig in and look at the architecture a little bit. So the weights are now on Hugging Face. You can check this out. They have the model card and all the information. I'm sure people will quickly start working with it. So you can check it out on Hugging Face, all the details. It is, like I said, open weights. And in today's video, I wanted to take a first look at GLM 5.2 as I try to take a look at all kind of the open weights, major open weights releases. And I feel like this one qualifies for that. So let's get into it. And if you like this video, please consider supporting the channel by joining Team Garage, which will give you early access to videos, or Team Garage Max, where you will get exclusive videos each week, as well as many other perks. I'd like to continue providing as much free, valuable content as possible, as well as better experiments on different hardware. So these memberships will really make it possible. Okay, so first things first, we could see it's a 753 billion parameter model, 1 million context window. They're saying it's stable to the limit, 2.9 times fewer flops per token, and MIT licensed. So looking at the architecture, and this is where it gets kind of interesting, is that it has this unique feature they're calling index share. And a 1 million context window is cheap to claim, but very expensive to run. So GLM 5.2's answer is to share the indexer. So the whole mechanism is that one indexer is reused across every 4 sparse attention layers. And this is a fairly lightweight indexer. So they place it at the first of 4 layers, and top K indices are used for 4 layers. So the net result is that it really reduces the computational cost of the indexer in this DSA architecture. And the payoff is per token compute drops 2.9 times at 1 million context length. So it really makes 1 million context actually possible. A lot of models claim 1 million context, but it's actually not very useful. So their claim is that the long context stays stable instead of degrading at the tail. And they say this was built to run, not just score. And these two design choices were key to that. So improved MTP layer, multi-token prediction layer. And this is for speculative decoding, basically drafting multiple potential tokens up front. It's a very common method to basically speed up models. And they found that there was up to 20% longer acceptance length using this method. So tokens clear per verification pass. And that's what's going to give you a lot faster of a model. And they also have selectable thinking effort levels. So you can kind of dial reasoning depth per task. So if you just need something routine, you can use it for cheap, or you can go deeper thinking for more harder agentic runs. And they do have a multimodal as well, text and vision in one stack. You can see some of the other details of the open weights model here. And they say index share cuts the cost of long context. MTP cuts the cost of every token after it. So let's get quickly through the benchmarks, and then I'm going to give it a couple tasks so we can see the output. So these are several reasoning benchmarks versus the rest of the field. The blue one, bluish green, is the top for open weights models, and the gold is just the overall winner. And you can see compared to the predecessor GLM 5.1 and some of the other open source, well, this one's not open source yet, but some of the other models in its general field. It's very competitive, beating several of them. Nice jump up from the previous generation. Still, obviously, is going to lose to like an Opus or GPT 5.5 even, but it's at least within the ballpark on some of these. And actually, in this one, it beat each of those as well, the AI ME 2026. Coding benchmarks, probably the most important, right? It has a real big jump here. Like this SWE Bench Pro one, you've probably seen a lot. This is for real world software engineering, and it easily beats these other models. Even beats GPT 5.5, a bit under Claude Opus, but definitely still in the same ballpark. And you see the other ones as well. Big jump up from previous, and compared to DeepSeek V4 or the most recent Quen, it's significantly higher. Agentic tool use, which is important, right? We're all going to be using this in our agents. Scored very high, second only basically to Claude Opus 4.8. This is the 4.8 version. It beat GPT 5.5, which is interesting because that's what I'm usually using in my Hermes agent. So it would be superior, at least based on this benchmark. So that's the honest scoreboard. The benchmarks are pretty impressive for an open weights model. I think compared to other open weights models and other Chinese models, the most recent Quen model, it's definitely seems, at least in terms of the benchmarks, it seems superior. And it was even managed to beat GPT 5.5 on a couple different benchmarks. So the verdict is it is the strongest open weights model on this board, and it is trading blows with, but not yet beating the closed frontier models. Okay, there you have it. Ran quickly through the architecture. There's some interesting things there, and as well as the benchmarks we always like to check out. But let me now give it a couple tasks. Okay, so we're going to be running this in Hermes Agent, which I often do with these models. I need to update it. You can see that happening in the background. But the first task is the one that you've probably seen me do before. I'm asking it to build a single HTML file, no build step, for a One Piece meets Star Wars game that has a full screen hero section with a dark background, a rotating 3D sphere, and 3.js with custom GLSL fragment shader that makes it look like a glowing planet. A sphere slowly rotates on the x-axis. On scroll, GSAP animates the sphere, scaling down and fading out. As the text headline fades in, the headline has a framer motion stagger entrance and works in Chrome, no npm, CDN imports only. So you've seen me do this before. It's a surprisingly difficult task. Okay, you see we just switched to GLM-5.2. So we're going to be doing it through OpenRouter. Let's initialize the agent here. Make sure everything works properly. This just came out an hour or so ago, although I'm sure people had it in preview. Okay, so let me give it that task, and we'll see what we get. Okay, it's built. Let's take a look. Okay, good start. The sphere itself looks excellent. I don't know if you guys can tell from the screen, but the texture is something. It looks really, really good. And the stars in the back look nice. So it has a nice glow around the edges. Let's scroll to begin. So it should fade out and get smaller, which it seems to be doing. Yeah, it did a really good job on the textures of this. But we get no headline. So it's supposed to have like a headline in that stagger style. We just get this kind of line down here. So it missed the headline part, which often it seems to be an issue. I can see if I can, I don't know if you can see it, but just for a second it pops up. This happens a lot with different models. It has an issue with the header, but the sphere itself looks great. Okay, so the next task I'm giving it is a research and then reasoning and then planning task. Kind of a couple different functions altogether. So this is going to test agentic workflows and tool use and, like I said, reasoning and planning, which are important. So the prompt was, can you research papers in the last 3 months about agent harnesses or workflows that enhance the capabilities of AI models compared to their baseline? Summarize the top 3 in terms of legitimacy, effectiveness, reproducibility, and then plan out an experiment to reproduce this paper on my PC, which has a RTX 3060. Okay, we got our results. Top 3 papers in the last 3 months. Number 1 is Life Harness, adapting the interface, not the model. 2 is Meta Harness. And 3 is SIA, self-improving AI with harness and weight updates. So It took a little while to do this actually in the end, but it was a fairly deep research task. You can see the summaries here are pretty good. Um, Pretty well formatted, I would say. Gives me the results, gives me the why, gives me the paper itself, the method that they use, any like GitHub repos that they have, reproduction plan. Here we go. We're gonna do the life harness. And if you keep watching my channel, I'll probably actually do this video at some point. This was a real research task I had for it. The main method of life harness is it evolves 4 runtime harness layers: an action realization, environment contract, trajectory, regulation, procedural skills from observed failures. The model stays completely frozen. Interesting. The results are pretty good here. 116 of 126 settings improved. Pretty significant gains on benchmarks. So I might actually do this. So look forward to that video. But as a task, I think it handled it very well. No issues with the tool calling, even though it was a complicated task. I didn't have to, baby it or anything like that. I think it did fairly well. Okay, so that was the research and planning and reasoning task. Last one I'm going to give it is the same one I gave to Fable. And this is the kind of fun game development one. This is an old game I had. You can see kind of the different assets I got. It was kind of like a Civ style strategy game. I'm going to I'm going to give it the folder that has all this assets for this game. This was just a demo I made. And I'm going to tell it to make a like Mario style 2D platformer. Okay, so I said, look in this folder. There are game assets here. I want you to use whatever game assets you find there to create a Mario style 2D side-scrolling platformer. Just one stage as a demo. I'll let you do whatever you want creatively. So we'll see how long this takes. And what kind of results we'll get. I'm not exactly sure. You remember, this is what Fable made. So I'm not expecting on this level. That's unfair, but just as a comparison. If it can even produce anything close to this, even a functional game, I'd be pretty impressed with it. This is really using the vision aspect as well. You can see we're really testing the multimodal because it needs to check all these assets. I didn't tell it what was in there. I didn't tell it which files to use. But it needs to look them over to decide which one it wants to use here. Making some progress here. You can see that it's already built a lot of the game. The game menu looks great. So it's now kind of testing, you can see. Very good tool usage, I would say. The tasks I've given it so far have tried out a lot of different tools, and there's been no kind of trip ups, which can be common with these newer models when everything isn't quite ironed out. And by the way, for the first 2 tasks, it cost us $3.83. And we're using OpenRouter, but I actually just switched to a new portal because I wanted to just try it out with a different one. So we're going to see how much it costs right now. Right now, it's pretty cheap, but let's let it work to the end. Hey, it's done. The game is Mint Legends Forest Quest. Let's see how it works. Be curious to see. Here we go. It's pretty cute. Mint Legends Forest Quest. Guide Banana Slinger through the enchanted forest. Stop enemies, collect coins, and reach the flag. Okay. That's me. Collecting coins here. It looks pretty good. It's a bit more simple than the Fable one, which was kind of expected. But it has all the mechanics, right? Hope I died there. And these are all characters. These sprites are all assets from the game. They're a little bit small, but they are working. Pretty fun. Okay. Ouch. Yeah, that looks good, I would say. It actually looks pretty good. So like I said, not Fable 5, but I wasn't expecting, but it actually did one-shot it. Like, it didn't ask me for anything while it was doing it. It just built it top to finish. And it only took like 20 minutes or so, I would say, from where we were. And there you go, $1.38, $1.38. I would say that's not too bad. And some of these elements, like the trees, I believe, were in that folder. These sprites were in the folder, but like these mountains weren't. But it made all of that. There you have it. That's my first look at GLM 5.2. I would say pretty impressive in terms of like an open source model. The first task, it did fairly well. It didn't do the headline, so it wasn't perfect. But a lot of other frontier models weren't able to do that as well, and it created the sphere that looked really great. The sphere looks really good. Then in the research task, I think it did really well as well. And then we got this game, which is pretty cute, and did it very well without any screw ups. There's nothing like weird in the controls or anything, which is actually a pretty big deal. And there you have it. So this has been GLM 5.2. Please leave your comments. What has your experience with the model been so far? Let me know. If you like the video, please leave a like, please subscribe, and I'll see you in the next video. Thank you for watching.